Hi and welcome back. In this video we're talking about dictionaries and objects, and we're going to introduce this concept of object-oriented programming. Now, the way I've got planned to introduce this to you, I'm pretty chuffed with. I think it's going to be quite understandable. So let's get on it and see how it turns out. We've looked at dictionaries as things that we can use to represent things in our program. For example, we can have a dictionary that represents a student. And we can say, my student is equal to this new dictionary that has a name and potentially has some grades. Something like that. Now, in our program, this dictionary represents what we think of a student. And in other parts of our program, we may do things like print out the student's name or calculate the average grade of the student and use this dictionary as though it was a student. Even though, of course, we know that real students in the real world have a lot more properties like an address and, family and things like that. In our program, we don't care about those other properties. We only care about the properties that we're going to use. So in our program, this dictionary can represent a student. And if we expand our program and we need more properties, we can always modify the structure of this dictionary and add them in. And this concept of having something that represents a real-world entity is pretty powerful in programming, and it allows us to start thinking of our programs in terms of what they do as opposed to how they do it. Let's move on and assume we want to calculate the average grade of this student so that we can, for example, put it in some sort of report somewhere. I think you can already calculate the average grade of this student quite easily, so I'm going to ask you to pause the video and give this a go. Try to implement a function that will return the average grade of this student. I hope you got that. What we're going to do is we're going to define an average grade function. It's going to take one parameter that is going to be the student, then a colon at the end, of course, and all it's going to do is it's going to add up the grades that we're going to do with the sum of the student grades, and it's going to divide that sum by the length of the student grades. The length, again, is the count of how many there are, and there are 4 in this case. And naturally, it's going to return that calculation. So now if we wanted to print out the average of my student, we can do that. Again, all we're doing here is we are evaluating my student. It's just a dictionary. We're calling the average grade function with that as an argument. So the value of my student, this dictionary, will then go into the student parameter. And that's going to return these calculations here. And then we're going to print that out. So let's run it. And as you can see, we get 86.75, which sounds about right. However, and here comes the interesting bit, there is a flaw with this entire program. I'm going to just delete that. The flaw is not in the code. The code's totally fine. It does what it's meant to do. It calculates the average grade. The student is a dictionary that's defined up there. All the code works, and it prints out, or it gives us the value that we want. But the flaw is in its design. Not user interface design, but in software design. And this is a concept and a whole topic that the majority of coding tutorials out there just completely skip over. But I think it's pretty important, and I think it's a good way to explain object-oriented programming. The flaw in the software design is that these two functions are essentially unrelated, even though they are very closely or seemingly close related. They are essentially disjoined. And what I mean to say by that is you've got this function, and in a large program, potentially you could have a function somewhere in an entirely different file altogether that gives you the average grade. And in a different file altogether, you could have this student. So these could be in completely different places physically in a large project. However, what we say that these two things are tightly coupled in that the average grade function requires that the parameter be a dictionary, and it requires that the parameter have a key grades in it in order to be able to fulfill its purpose. It's totally fine for a function to have those requirements, but not when it's also possible for the function to be in a completely different place. Because then let's say you wanted to change grades for resource or for results, for example, you'd have a mayhem if you've got functions all over the place that rely on the student to have a grades key, but now you change it. So this is the flaw in the design of this program. We've got a function that is not living with this student, but is tightly coupled to that student, or to this dictionary structure. So it would be great if we could have our function living inside the dictionary, so that it lives in the same place as the data that it acts on. Something like this. Let's say we add a new key here, that's the average, and this is like something that calculates average. This could be a function that calculates the average of a student, of this student specifically. So currently, with these grades, this should be 86.75, but of course, if we add another grade, say 100, this should go up to like 90 or something. This value here must be a function in order that it can be recalculated every time that the grades change. However, we cannot do that with a dictionary. A dictionary will not allow us to put a function here that acts on the data inside that same dictionary. It's just not possible. Sorry. So we must use objects for this, because the object is the natural progression in this dictionary usefulness thing, where it will allow us to act on the data that the object holds. So we can begin of thinking of objects just as a starting point of a thing that holds data, in this case a name and grades, and it can also hold actions to do with that data, in this case calculating the average. So I'm going to keep that here for as we implement our object definition, we're going to refer back to it. So what I'm going to do now that we know that an object stores data and actions to do with that data, is I'm going to define that object. And it's going to be quite confusing to begin with, but I want us to stick to it. We're going to define the objects, then we're going to create the objects. Those are two distinct steps. And then we're going to explain exactly what's going on. What I want you to understand in terms of these objects is that they are just things that store data. The data can be the name and the grades, and it can also store these actions. So let's start by defining what an object looks like. And we do that with a class. Okay, the class is something that defines what the objects are. Inside the class, so we've got the keyword class, then we've got the name of the class, and normally in Python they start with an uppercase letter. And then we've got a colon. Now we know that after a colon, things must be indented more. And as you can see, REPL it already suggests that we put 4 spaces in front. Now inside this class, indented as 4 spaces, we're going to define 2 functions. And this is pretty weird because so far we've been defining functions in the top level of indentation, that's at the very left of the page. Now we're going to define them inside the class. And that's going to mean that the class is going to contain these functions. Okay? Let's start by defining a function which is a special function called underscore underscore, that's 2 separate underscores, init underscore underscore. In Python, these functions with 2 underscores in front and 2 underscores at the back, they are special functions, and they're called dunder functions. So this would be a dunder init, dunder for double underscore. This init function is going to take 3 parameters. The first one is self, next one's going to be new name, and next one's going to be new grade. These parameters can be called anything you want, but I'm picking self for a particular reason, and these can be anything, but these are going to be the name and the grade that we're going to store in our object. And inside it, we're going to say self.name, oh, completely wrong there, self.name equals new name, and self.grades equals new grades, and I'm going to make sure to make it new grades there. Okay. Moving on to the second function is going to be an average grade function, pretty much like the one we've got here. I'm going to call it average, and it's going to take a single parameter called self. Then again, the colon, and then what's going to return is the sum of self.grades divided by the length of self.grades. So I appreciate this is just me typing and you watching, and now let's begin to explain exactly what is going on here. But before we can do that, before we can explain the scary syntax here, we have to define, or rather, we have to create an object. What we've defined here is we've defined the object structure. We're going to now create an object. So we're going to create an object called student1. And the way we create a new object in Python is we call the class like so. So we've got an opening and closing bracket there, and that creates a new object of type student. And so this student class now gets called using these brackets as if it were a function, and that creates a brand new object. So what is an object? And think of an object as just something that can store data. And we are going to tell it what data to store. So inside this student call here, sorry about that, we're going to put two things. We're going to put Rolf Smith, and then we're also going to put 70, 88, 90, and 99. Now, what's happening is, the first thing that's going to happen is this call here is going to create a brand new object. An object is a completely empty thing, or more or less empty thing, that allows us to store data and it allows us to store actions. When the object is created, that's created before we call any of these functions, then it immediately calls this dunder init function. So the object is first created, and then it immediately calls this dunder init function. The new empty object that was just created gets passed to self as the first parameter. So self is now an empty, blank object that has essentially nothing in it. And the way that Python is structured, it then gives Rolf Smith as a new name, the second parameter, and this list as new grades, the third parameter. I'm so confused thinking about zeros and ones here. So, very, very important. Self is a blank object that was created before we call this dunder init function. New name is the first argument here. New grades is the second argument here. Now, we know that when we get into the first line, we now have these values. Self is a blank object, and now what we're going to do is we're going to use the dot to access something inside this object. And what we're going to access is this name thing. Now, let me tell you, because it's a blank object, it does not have anything called name inside it. It doesn't have a variable called name inside it. So what this is doing is it's creating a new variable called name that lives inside of this blank object that we are calling self. Of course, you can call it whatever you want. You can call this my boject if you want, or you can spell it right and call it my object, and that's totally okay. Yeah, that's totally fine. You can do that if you want, but the convention is to call it self. Okay. In Python, it will always be called self, even though you can call it whatever you want. So we've got this empty object, and inside of it, in this dot, we're defining the name variable. And we're giving that variable the value of new name, which is Rolf Smith. So now, what was previously a completely blank object, now is no longer blank. It contains this name variable. And in the second line, we're doing the same thing. We're getting our now not blank object, and we're defining the grades variable inside of it. And the value of that is the new grades list that we passed in here. Now, before we move on to the average function, I want to make sure that this is clear. And if we print student1, this is the object that we've created, .name, we're going to get... Oh, we've done something incorrect here. Oh yeah, sorry, we've missed something here. I'm just going to put none there for the time being. If we print out student1.name, we get Rolf Smith. That is what we defined up here. All that's happening again, student is creating an empty object, and that's getting passed to the dunder init method as self. New name is Rolf Smith, new grades is here, and then all we're doing is we're assigning new variables inside of self, and we're giving them the values that we passed in. So the student object is an entity that can store data. And the way we store data in it is by using this .name. However, student1 knows that it is a student with capital S. And the way we can do that is we can access some special property of it that is __ class. We can run that, and then you see that it is class student. That's the type. So student1 knows it is a student thing, and it has now a name and a grades defined in there. If we were to define student2, make it equal to another student, for example, Jose, and give it some grades of 50, 60, 99, and 100, I got better towards the end of the term, then we can print student2.name. We can run that. And notice how it says Jose, and we can print student1.name. And notice how now it says Jose and Rolf Smith. So these two things are completely different entities, completely different things. They both know they're students, and they both have this name variable that we've declared in here. But of course, if we wanted, each one could have a different property. You know, that's something that you can do if you were so inclined. And they don't care about exactly what they are. All that they know is that because we've defined it inside here, and we've called this dunderInit method, they now have a name, and the value of that name is what we passed in here. Nothing magical is going on. Just data has been passed from one place to another, and that's really what programming is all about. Okay, now that we've created our object, and we know that we can create multiple objects, and they are all just independent blank things that we've assigned these variables, we're ready to go into the next step, which is looking at this average. Let's do that in the very next video. I'll see you there.